For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. In our last lesson, we learned about some factors that affect the reaction rate of chemical reactions. We looked at how the nature of reactants can affect the reaction rate, as certain reactants react more quickly or slowly with other reactants. We also looked at how the surface area of solid reactants can also be a factor, as a large surface area creates more contact, thus quicker reaction, and a smaller surface area creates less contact, thus slower reaction. In today's lesson, we are going to learn about two more factors that affect the reaction rate of chemical reactions: temperature and the concentration of reactants. Let us get started. Temperature often has a large effect on reaction rates. Generally, when the temperature of a reaction mixture rises, the rate of reaction speeds up. This is because when molecules are at a higher temperature, they contain more thermal or kinetic energy. The faster movement of molecules means they collide more frequently and with greater energy, so that the reaction will take less time to complete. The reverse is also true. When the temperature drops, the rate of reaction slows down because the molecules begin to move more slowly. Students, let us do an activity. Think of a common example where reactants are purposely kept cooler so as to slow down a chemical reaction.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. This lesson is just starting to heat up. What example did you think of? If you said that food is kept cold in refrigerators to keep it from decomposing too quickly, then you were correct. When food is left in warmer temperature, like under the hot sun, or even in a warm house, it begins to decompose much faster. When the kinetic energy of a reactant's particles increase, like the particles inside the banana you just saw, the particles begin to collide more often and with more energy. Open heart surgery is another example where reactants, or in this case, the patients, are cooled down in order to slow the progress of a chemical reaction. The patient's bodies are cooled down to slow the rate of biological reaction. This gives the doctors more time to properly complete the surgery. An increase in the concentration of one or more reactants can also have an effect on the rate of reaction within a chemical reaction. When the concentration of a reactant increases, the rate of reaction increases. This is because an increase in concentration means the reacting particles will come into contact with one another more often, thus causing the increase in the rate of reaction. Students, let us do an activity. Draw a picture of a chemical reaction where there is very little concentration of the reactants. Then, label the reactants in your drawing.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did your drawings turn out? I bet some of you are really good artists. You were correct to draw a picture where one or both of the reactants are a solid. Solids, such as metals, have particles that are clumped together. They have very little concentration, which makes it difficult for the reacting particles to collide. When we examine gases involved in chemical reactions, as opposed to solids or liquids, it is pressure rather than concentration that increases the rate of reaction. Pressure has no effect on the rate of reaction of solids and liquids. However, pressure increases the concentration of gases, speeding up the rate of a chemical reaction. When the reacting particles in the gas are compressed, the same amount of particles are present, but in a smaller container. This means the particles will collide more often. Let us use a can of soda as an example. Within the can, the carbon dioxide gas, which keeps the beverage carbonated, collects at the top of the liquid. If you shake that can of pop, the carbon dioxide mixes with the soda. The gas expands, so if you open the pop right after shaking it, the pressure that has built up inside the can will release, and the soda will blow out of the top of the can. In today's lesson, we discussed two factors that affect the reaction rate of chemical reactions: temperature and the concentration of the reactant. We learned that an increase in temperature usually increases a rate of reaction, as it causes reacting particles to speed up, while a decrease in temperature usually slows down a reaction because the particles slow down. We also learned that an increase in the concentration or pressure on reactants can have an effect on the reaction rate. A higher concentration of reactants increases reaction rate in solids and liquids, while a lower concentration decreases the reaction rate. Pressure has the same effect, but it relates to gases rather than solids and liquids. This is all for today's lesson. Until next time, thank you, teacher. Thank you, students.